Okay. Here's the equation. We want to get rid of our denominator. Always, if there's a denominator in an equation, we do our best to get rid of it, and usually we can. In this case, that's a class. It was pretty neat, you know. What do you multiply both sides by in order to clear the denominator? Somebody said 6. Well, there's a 6 there and a 6 there, but you can't multiply just by 6. If you multiply by 6, it doesn't really affect the denominator, okay? And then somebody said x minus 6, which is even better, okay? Because that would clear this denominator. If you multiply this by x minus 6, your denominator divides out. But this denominator doesn't, okay? And then somebody pretty quickly said 6 over, you multiply by x minus 6 squared, because that takes care of everything. Well, let's see how that works. We haven't seen one like this, although they have occurred in homework. So we multiply both sides by x minus 6 squared. And let's write it out just as it is. We're going to have x minus 6 squared times 4 plus 5 over x minus 6 plus 6 over x minus 6 squared equals, of course, x minus 6 squared times 0. Well, x minus 6 squared times 0 is just 0. And to do this multiplication, we use the distributive law. We get 4 times x minus 6 squared plus 5 over x minus 6. And I'm going to say it's times x minus 6 squared over 1, just so we can keep our fractions straight, plus 6 over x minus 6 squared times x minus 6 squared. Should have left myself more room, but naturally I didn't. Over 1, right? So that's the most efficient way to write it out at this stage, okay, when we're not allowing cancellation. So you get 4 times x minus 6 squared plus, well, this can be written as 5 over 1 times x minus 6 squared over x minus 6. And this has 6 over 1 times x minus 6 squared over x minus 6 squared, because in both cases we would get the same numerator and the same denominator. If we multiply these numerators, we get the same thing if we multiply these numerators, right? If we multiply these denominators, it's the same as if I multiply these. So this is identical to this. Similarly, this is identical to this. The product of the numerators is the same, and the product of the denominators is going to be the same. So that justifies writing it in the form I've written it. Then, this is going to be 4 times x minus 6 quantity squared plus, well, x minus 6 squared over x minus 6 is just x minus 6. If you divide the square of something by itself, you just get the first power, this exponents, right? Something squared divided by the same thing to the first power is that thing to the 2 minus 1 power. So we have 5 times x minus 6, and 6 over 1, of course, is just 6, and this divided by this is a quantity divided by itself. This is just 1, so this is 6. That equals 0. Okay? Now once you've got this, you're pretty much home free. All you have to do is expand the square. And you don't do this by magic. You do this 3. And the ellipsis here tells you that you want to write out x minus 6 times x minus 6. And I'll actually do that over here. Okay, we have x times x minus 6 times x minus 6. And that equals x squared minus 6x minus 6x plus 36, which is x squared minus 12x plus 36. So we're going to have 4 times x squared minus 12x plus 36 plus 5x minus 30 plus 6 equals 0. Then multiply both sides by 4, we have 4x squared minus 48x plus 144 plus 5x minus 30 plus 6 equals 0. And then we just simplify. We add up all our x squared, but they're just a 1. Okay? Then we have minus 48x plus 5x, that's minus 43x. Then we have 144 minus 30 plus 6, which is 120, equals 0. And now we use a quadratic formula. Okay? And we know how to do that. Everybody's demonstrated their ability to use the quadratic formula. If I write it down for you, next time I'm not going to write it down. Okay? You got to know it. On a test, and there'll be a test coming up, maybe as early as next week. Okay? So we got to see how you're really doing. I can kind of see by your quizzes. We want to have you actually demonstrate that on the test, because we need to give you a grade for this course. And remember, it's possible to pass this course, but not the 161 course, okay? And of course, if you pass the 161, you do pass this course. I wouldn't count on that. Okay. Until you have a test or two under your belt in 161, you really don't know how you're doing there. So, and I'm saying this more to people who might not be here than to the people I'm looking at. And I said it before. If you find you're in over your head in 161, don't go and drop it until the last possible date, so you can stay. Excuse me. So you can stay in here, because if you drop 161, you're out of here, and you can't be here. It's not my rule. I'd let you stay here all semester, but it's the system's rule. It's not even the college's rule. It's handed down on a stone tablet from Richmond. Okay? I don't agree with that, but there are good reasons for it as well. Okay? So, you stick in the pre-calculus class and keep working in that class. Learn all you can, because then if you have to repeat it, you'll be that far ahead. Stay in this class to learn as much as you can. Okay? Now, having said that, people I'm talking to right now don't appear to be in over their heads. Okay? Don't appear to be. You won't know until we do a test and see what you really know, and see if you're learning what you need to succeed in pre-calculus. Okay? There are some people who just aren't doing the assignments at all and aren't showing up for class, and I fear that maybe they've given up, and that's not a good thing to do. You don't give up. You keep learning as long as you can, because then if you repeat the course, you're going to be in much better shape. You're going to have a big head start. Okay? Again, talking more to people who aren't here than to the people who are.